to Ctrl-Alt-Evict channel. And today, as we discussed previously, like longest consecutive subsequence in my part one video. Now due to like some reason, I just dropped the video, and I'm continuing where I dropped. So I was in the beta approach. So let's discuss like where we are. So in the beta approach, we are going to run uh, we are going to run this code onto the editor to test whether it is working or not. Please, if you don't if you don't do not start with this video, please go on to the part one where I left. So I just start where I left the video. So this is a part two video, right? So basically, first of all, we have copy paste it and run this code. Okay, then we get the 4 and 9 as the answer. So this is the like better approach. What are the time complexity is big O of log n, and the space complexity big O of 1. Okay, so why it is the like time complexity is like big O of n log n, because we are sorting the nums. Then after that, we iterating the loop, and if there is any number is available, like num minus 1, last smaller number is available, then we iterate that one. Okay, so let's come to the optimal approach. So in the optimal approach, what happened, like if we want to like reduce the time complexity, and from n log n plus n to n. So how do we do that? So how can we do that? So basically we are using the set. So what is set? Which store the unique number of element, and what we check, like if this number contains any minus number, then we skip it, and we are taking the smallest number within the array, which is to be the unique. Smallest number means like if we have a like array like this one. Okay, so we will check like either any number which is the number which not to be like the like n minus 1, like any number num minus 1 is not available in the array. So like 100, num minus 1 is available into the set. So let's create the set as well. Set, I think this is the all unique number in the set. So this is set. Okay, and this is set which is store the all nums within the set, and we will check like any number minus 1 is available in the set or not. If there is any available, so we will skip that part, because we are going to the minimal number, or you can say unique number, which is a start from which the number minus 1 is not available into the array. Okay, why? Because of this we can because okay, first of all, like why we are using this, because when we do any number, num plus 1 is available, so we are iterating the loop. Okay, so if we come to the 100, so it will iterate 100 plus 1. 100 plus 1 is available, no. If we come to the 4, is 4 minus like 4 plus 1 is available, no. Come to the 200, 200 plus 1 is available, yes. 209 is available, less than 200 is not available, so we are taking as a unique. 1 minus 1 is like 1 plus 1 is available, yeah. 2 1 2 plus 3, this is also available. When we come to the 2, so it will also iterate the same 2 3 4 and 5 to overcome from this. So we will find the smallest number, which is to be the unique, which like the greatest number is available but not less than that num minus 1 is available. Okay, so like we are, let's imagine like we have 100. Okay, so let's write the code of there. Okay, so this is a basically a optimal approach, so we are using the same thing. Okay, and we are also iterating this one, and we are removing that part also, and we are taking let let longest. So we are taking the longest equals to 0. Okay, and we are iterating the num for that num of nums. So we will check if we are taking the set. First of all, const set is equals to new set nums. Okay, if not set dot has num minus 1. Okay, num minus 1 is not available, Then we will go in this side, and we are iterating start. Okay, so for num of set, sorry, num of set, and we will check like set dot num as num. So ret present equals to num, and we are taking the count as well, and ret count equals to 1, and we are using the while set dot has present plus 1, present plus 1 is available. Then what we do, we are increasing the plus 1 plus plus, then count plus plus. Then after that what we check at here, after that we check like after doing the operation, we are checking like longest equals to count. So we have a count. Mat dot max longest comma count. Okay, then if we got it, then return longest. Okay, so every time the set num is available, then we start, then by set dot has plus one, then we do count, and up count that return longest. Okay, so we will do this. Let's run the code. 4 and the 9. Okay, so why we are doing this condition? So this condition is doing like if we have a 100 number, 100 minus 99 is available? No. So we will start the loop 100, 100 plus 1, 100 plus 2, 100 plus 3. If we come to the 1, okay, so 1 minus 1, 0 is available. 1 minus 1 is available. So we will not start from that there because we have to start from the 0, because it will basically reduce the time complexity, because we are not iterating 1 minus 1. We are taking the smallest number, which is to be the unique at here. It's a 0. Okay, so we are taking that number. And so what are the time complexity? The time complexity is big O of n. And what are the space complexity? Because we are storing the n number of element and it's to be the unique, so this is the space complexity. Okay, I just want to add one more question within it. I think there is no written question, so I just want to add like if we have a number array and we want to find the like the element within the array which are the subsequence, so how can we find it? Okay, so let's write the code that best sequence equals to this one, we are taking it. Okay, then after that what we do, that uh, subsequence subsequence equals to this. Okay, so what happened, like whenever the count is greater than longest, so that time we are assigning the uh, count number into the longest. So at the same time what we are doing, we are assigning like subsequence equals to num, and we are also write subsequence dot push, that is to be the present. Okay, so we are also assigning that present at here, subsequence dot present, and we subsequence we push it, and here we write the condition if count is greater than longest, dot max, that is a count, and we are also doing best subsequence. In the best subsequence we are getting it equals to like subsequence, so we are getting. Okay, so here what we are returning a two object like longest and best subsequence. Okay, so let's check what are the output. So longest equals to 4, best subsequence 1, 2, 3, 4, and that is a 9, and the subsequence is 0, 1, 3, 4, 5, 6, 7, 8. Yeah, so that thing I have done. I think that's it from the code, and I hope you understand. And yeah, that's it. And one more thing I want to add. So this is a like this question is asked into the Google interview question. So please focus, please understanding this code as well. Thank you very much.